Hi everyone, I am Polash Kumar Bora. Today again I will be solving question paper of 2019 Assam Higher Secondary Education Council. And already I have started few problems we have done, and this is a continuity of the previous video. Here again I will be solving few more problems, and this is a little bit of longer video, so I don't want to waste much time here. Okay, let's go to our main topic. Let me consider question number 7. We have to find dy dx of that given function. Okay, for that let me recall one of the this result. 2 tan inverse of x or theta is equal to cos inverse of 1 minus theta square by 1 plus theta square. Let us do the problem now. Suppose theta square is equal to 4x cube. Okay, fine. Now let me take derivative of this with respect to this x. Then what do I have? Twice theta d theta dx is equal to 4 into 3 x square. This I can cancel, so it will be 2. This implies d theta dx will be equal to 6 x square by theta. So this is equal to 6 x square divided by theta. I can write square root of 4x cube, square root of 4x cube. So this is equal to 6x square divided by 2x root over x. So this and this with 1x cancel out. So this becomes 3 into root over x into x. This x I can write root over x into root over x divided by root over x. This will get cancelled out. So we are left with 3 root over x. Therefore our y becomes half cos inverse of 1 minus, and 4x cube we assume it to be theta square, so I'll replace it by theta square by 1 plus theta square. So this is equal to half. In place of this I can write 2 tan inverse of x. So these two to get cancelled out, we are, sorry, this is not x, this is theta, so it becomes tan inverse of theta. So this implies y is equal to tan inverse of theta, and if I take derivative with respect to theta, then we have dy d theta is equal to, and d theta of tan inverse of theta is 1 by 1 plus theta square. All right, but we are asked to calculate dy dx. Now dy dx, this is equal to dy d theta into d theta dx. If I use chain rule, then I will have this. So this is equal to dy d theta, already we have calculated, it is 1 plus theta square, and d theta dx is found out to be 3 root over x, so it is 3 root over x. So this is equal to 3 root over x divided by 1 plus, and you see our theta square is 4x cube. I will substitute it here. 1 plus theta square is 4x cube, and that is our dy dx. Okay, let us now consider the OR part of question number 7. Determine the set of all points where the function fx is equal to x into modulus of x is differentiable. For this, first of all, we need to understand what is the modulus function. Modulus of x, we can write it as x if x greater than equal to 0, minus x if x less than 0. And this implies f of x, this is equal to x into modulus of x, so this becomes x into x if x greater than equal to 0, x into minus x if x less than 0. So this is equal to, now you see. Now for x greater than 0, fx is equal to x squared, and it is a polynomial function. Now we know that polynomial function is differentiable on R, so it is differentiable. Okay, no problem up here. If I consider for x less than 0, and it becomes fx is equal to minus x squared. Again, minus x squared is a polynomial function. Like this, we can say it is also differentiable on R. The point I have not considered is x equal to 0. We will check at x equal to 0 now. Now we have f dash of 0. If I use the definition of derivative, limit of fx minus f0 by x minus 0 as x tends to 0. Now first we will be checking f dash of 0 plus. So limit x tends to 0 plus, our fx will be, as x tends to 0, our fx is x squared minus f0 is 0 by x. So this becomes limit of, and this becomes x, as x tends to 0 plus, it becomes 0. Now let us see f dash of 0 minus, it is limit x tends to 0 minus f of x minus f0 by x minus 0. So this is equal to limit, that minus x square minus 0 by x minus 0. So this is equal to limit of minus x, this is 0. So therefore f dash of 0 plus is equal to f dash of 0 minus. That means it is differentiable at x is equal to 0. Our fx is differentiable for all real numbers. This is our answer. Okay. Okay, question number 8, we have to evaluate this integration, and we'll do this integration by parts, not by parts, by substitution. Suppose I is equal to integration. Okay, we will substitute x is equal to sine theta. Okay, if I take derivative with respect to theta, then I have dx is equal to cos of theta d theta. Therefore, okay, so this is equal to integration by integration of 1 minus sine square theta is cos square theta, and square root of cos square theta is cos theta into cos theta d theta, and this get cancelled out. So this is equal to integration. So this is equal to 1 by sine of theta minus sine theta by sine theta d theta. So this is equal to integration cosec theta minus 1 into d theta. So this is equal to integration, and what is the integration of cosec theta? It is log of cosec theta minus cot theta minus the integration of d theta is theta plus c. So this is equal to log of, so cosec theta is 1 by sine theta minus cot theta is cos theta by sine theta. So this is equal to log of sine theta, and is 1 minus cos theta minus theta plus c. So this is equal to log of, so sine theta is, we assume it to be x, and 1 minus this cos theta I can write square root of 1 minus sine square theta, but sine square theta is x square minus sine theta is x, so theta will be sine inverse of x plus c, and this is our answer. Okay, let us do our part of question number 8. Evaluate integration cos 8x plus 1 divided by tan twice x minus cot twice x dx. Okay, to solve this problem, we have to know some formula of trigonometry. Okay, let me recall those formula. Cos of twice x, this is equal to cos square x minus sin square x, and also this is equal to 2 cos square x minus 1. Then we need sin twice x, this is equal to 2 sin x. Now let me consider I is equal to integration. So this is equal to integration. This 8x we can write 2 into 4x plus 1. This is sine of twice x by cos twice x. dx. So this is equal to integration. If I use this formula, then it will be 2 cos square x. Our x is 4x minus 1 plus 1, and if I take LCM, this sin twice x. So this is sin square twice x minus cos square twice x dx. So this is equal to, this get cancel out. So this is equal to cos to the power 4x, and this will be going to the numerator, 2 sin twice x cos twice x divided by, okay, from here if I take minus common, it will be cos square twice x minus sin square twice x. So I can use this formula. So it will be, so cos square, our x is twice x, sorry, it is cos of twice x, that is, okay, sorry, this twice x and dx, and so this is equal to integration cos square 4x, I can add cos 4x into cos 4x, and this 2 sin twice x cos twice x. If I use this formula, then it will be sine of 2 into twice x divided minus cos of 4x, and this 1 and 1 get cancel out. So this is equal to integration minus, okay, let me write 2 here. That means I am multiplying numerator and denominator by 2. Then this will be sine 4x. Let me write first. Then cos 4x dx. So this is equal to minus half. Let me take out. If I use this formula here, it will be sine of 2 into 4x dx. Okay. So this is equal to half integration. It will be sine of 8x dx. So this is equal to minus half, and integration of sine x is minus cos x minus cos x, but it is not x, it is 8x, so we have to divide by 8 plus c. So this is equal to minus minus plus, so it becomes cos of 8x divided by 16 plus c, and this is our answer. If you want to solve this kind of problem, you have to remember the formula of trigonometry. Then only you will be able to solve. Clear? Okay. Let us solve question number 9. Evaluate integration 0 to 1 3 minus x square divided by 3 plus x square whole square dx. Suppose I is equal to integration, suppose x is equal to root over 3 tan of theta. This implies dx will be root over 3 sec square theta d theta. When x is 0, when x is 0, tan theta will be 0. Actually it is 0 divided by root over 3, that will be 0. Tan theta will be 0. So tan theta is 0, that means 0 is, sorry, theta is 0. Okay, when x is equal to 1, then tan theta will be 1 by root 3. Theta is equal to 5 by 6. Therefore our I becomes 0 to pi by 6. 3 minus, if I do x squared, then it will be 3 tan squared theta divided by 3 plus 3 tan squared theta whole square, and our dx is root over 3 sec squared theta d theta. So this is equal to integration 0 to pi by 6. If I take 3 common, it will be 1 minus tan squared theta divided by 3. If I take common, 3 squared, so it becomes 9. And then we have 1 plus tan squared theta is sec squared theta, and this square is there, into root over 3 sec squared theta d theta. Then I can cancel here. Then sec squared theta, 1 sec squared theta I can cancel. Okay, therefore our I becomes integration 0 to pi by 6 1 minus sin squared theta by cos squared theta divided by, and okay, root 3 by 3 I can take out from the integration sign. Then this is 1 by cos squared theta d theta. So this is equal to root 3 by 3 is 1 by root 3, integration 0 to pi by 6 this, and this one get cancelled out. So this is equal to 1 by root over 3 0 to pi by 6. So cos squared theta minus sin squared theta is cos of twice theta d theta. So this is equal to 1 by root over 3, and integration of cos twice theta is sin twice theta divided by 2, and our limit is going from 0 to pi by 6. So this is equal to 1 by root 3. If I substitute the limit, then I will have sin 2 into pi by 6 by 2 minus sin 2 into 0 divided by 2. So this is equal to 1 by root 3. So sin of pi by 3 divided by 2, and this is 0. So this is equal to 1 by 2 into root 3, and sine of pi by 3 is root 3 by 2. So this get cancelled out. So our answer is 1 by 4. Okay, let us solve question number 9. And to solve this problem, we have to remember one result of definite integral. Not only one result, two results of definite integral. Let me recall those two results. Okay, these are the two results we have to remember for solving this problem. Suppose I is equal to, give it a number. Now I can be written as okay, after using the result, and this first result we have this one. Now I is equal to integration pi by 6 to pi by 3 1 by 1 plus root over 10 of, and you see pi by 3 plus pi by 6 gives us pi by 2 minus x and dx we have. So this is equal to integration pi by 6 to pi by 3 1 by 1 plus root over 10 of pi by 2 minus x, that becomes cot of x dx. So this is equal to integration pi by 6 to pi by 3 1 by 1 plus this root over cot x, that can also be written as 1 by root over 10x dx. So this is equal to integration pi by 6 to pi by 3, and it becomes root over 10x divided by root over 10x plus 1 dx. Okay, give it a number. Now let me do 1 plus equation 1 plus equation 2, that gives us, so I plus I, so this is equal to pi by 6 to pi by 3, and it was 1 plus 1 by 1 divided by 1 plus root over 10x dx plus integration pi by 6 to pi by 3 root over 10x divided by 1 plus root over 10x dx. So this implies I plus I becomes twice I. So this is equal to, if I use the second property of definite integral, which I have mentioned at the very beginning, then it becomes integration pi by 6 to pi by 3. So this plus this one. Then we have 1 plus root over 10x as the LCM. So in the numerator we have 1 plus root over 10x dx. So this get cancelled out. So we have integration pi by 6 to pi by 3 and this dx. So this is equal to x, integration of dx is x, and our limit is going from pi by 6 to pi by 3. So it becomes pi by 3 minus pi by 6. So it becomes pi by 6. So that means we have twice I is equal to pi by 6. From here we can say, or I as pi by 6 divided by 2. So this is equal to pi by 12. So this is our correct answer. Okay, question number 10. Solve the differential equation. So it is a linear differential equation, and that is of the form. So first of all, we'll convert our given differential equation to standard form. Then it becomes dy dx plus 2 by x y is equal to x log x. So here our p is 2 by x and our q is x log x. Now first of all, we'll try to find the integrating factor, and our integrating factor is given by e to the power integration p dx. So this is equal to e to the power integration, our p is 2 by x dx. So this is equal to e to the power twice log x. So this is equal to e to the power log x square. So this is equal to x square. This is our integrating factor. Then we'll multiply our given differential equation. Let me give it a number. It is 1 by the integrating factor. So 1 into integrating factor, that implies x square into dy dx plus 2 by x y. This is equal to x square x log x. So this implies it becomes d dx of x square y, and this is equal to x cube log x. This implies d of x square y, so this is equal to x cube log x into dx. Now integrating both sides, we have integration and with a constant of integration. So this implies integration of d of x square y, that becomes x square y, and integration of x cube log x, that we will do by integration by parts. Then I'll consider log x to be the first function and x cube to be the second function. Then log of x into integration x cube dx minus integration, so d dx of log x into integration x cube dx into dx plus c. So this implies x square into y, so this is equal to log x. Integration of x cube is x to the power 3 plus 1 divided by 3 plus 1 minus integration d dx of log x is 1 by x, and integration of x cube is x to the power 3 plus 1 divided by 3 plus 1 into dx plus c. So this implies x square into y is equal to x to the power 4 into log x divided by 4 minus 1 by 4 into 1 by x, and it is x to the power 4. X to the power 4 divided by x, that becomes x cube dx plus c. So this implies x square y, so this is equal to x to the power 4 log x divided by 4 minus, it will be 1 by 4, and this will be integration of x cube is x to the power 4 by 4 plus c. Now let me divide both sides by x square. Then we have y is equal to this thing divided by x square, so we are left with x square log x divided by 4 minus the x square by 16 plus c by x square, and this is our answer. Okay, question number 11. If y is equal to 3 cos of log x plus 4 sin of log x, then show that x square d2y dx2 plus x dy dx plus y is equal to 0. Y is equal to if I take derivative with respect to x on both sides, then we have dy dx. So this is equal to 3, and ddx of cos x is minus sin x, but it is not x, it is log x. So we have to take derivative of log x plus 4 ddx of sin x is cos x, but it is not x, it is log x, so we have to take derivative of log x. So this is equal to minus 3 sine of log x, the ddx of log x is 1 by x plus 4 cos of log x, and ddx of log x is 1 by x. This implies, let me multiply both sides by x dy dx. So this is equal to x and 1 by x that get cancelled out. So we are left with 3 sine of log x plus 4 cos of log x. Again, let me consider derivative with respect to x on both sides. Then we have d dx of x dy dx. This is equal to minus 3 d dx of sin x is cos x. As it is not x, so we have to take derivative of log x plus 4, and d dx of cos x is minus sin x into d dx of log x. Up to here, I think no one is having any problem. Now you see, this is d dx of UV form. So I'll consider this to be the first function, this to be the second function. So d dx of UV, that is x into derivative of the second function plus second function derivative of the first function. So this is equal to again, let me multiply both sides by x. So x into x, it becomes x square d dx of dy dx is d2y dx2 plus x dy dx, the d dx of x is 1. So then we are left with, as we are multiplying this side by x, so it becomes 3 minus 3 cos of log x. Let me take minus common here, plus 4 sine of log x. Okay, this implies is equal to minus, and you see 3 cos of log x plus 4 sine of log x, and that is equal to y, so it is y here. This implies, if I'm shifting to left hand side, then it becomes plus y, so this is equal to 0, and this is to be shown according to the question. That is our desired answer. Okay, question number 12. If a bar is equal to 6i cap plus 8j cap and b bar is equal to 3j cap plus 4k cap, then determine the vector component of a bar along b bar. The vector component of a bar along b bar is given by this formula: a bar dot b bar divided by magnitude of b bar, this into b bar. That means we have to calculate a bar dot b bar and magnitude of b bar. Okay, now here now a bar dot b bar, so this is equal to this into this, 6 into 0, 8 into 3 plus 0 into 4, so this is equal to 24, and b bar, this is equal to square root of this is square plus this is square plus this is square, so it is 3 square plus 4 square, 9 plus 16, so it becomes square root of 25, so this is 5. Okay, therefore 24 by 5 into 3 z cap plus 4 k cap, and this is our answer. Okay, find a unit vector perpendicular to each of the vectors a bar plus b bar and a bar minus b bar, where a bar and b bar are given. Let me recall. Suppose I have a vector here. Suppose this is a vector a bar plus b bar, suppose. Okay, and this is a vector a bar minus b bar. Then a vector perpendicular to both a bar plus b bar and a bar minus b bar is that means it is perpendicular to this as well as this is perpendicular to this one. Suppose this is a vector c bar. Then what is c bar? C bar is nothing but it is this vector cross this vector. That means if we want to find a vector perpendicular to a bar plus b bar and a bar minus b bar, simply we have to find their cross product. All right, okay, let us see now. Let c bar be a vector which is perpendicular to both a bar plus b bar and a bar minus b bar. Now a bar plus b bar is equal to, so we have to add the components, okay, scalar components of a bar and b bar. So it will be 3 plus 1 4 I cap plus 4 z cap plus 0 into a cap, and a bar minus b bar, that will be equal to then plus 0 into 10 plus 4. Okay, you got this how to add two vectors and how to subtract two vectors. I'll not be going in details about that. What is c bar? C bar is nothing but it is a bar plus b bar cross a bar minus b bar. Okay, and this is equal to Now this is equal to I cap, and I'm expanding along the first row. Then I have, so 4 into 4 is 16 minus 0 minus j cap. This and this is gone. So it's 4 16 minus 0 plus k cap. So 0 minus 8. So this is equal to 16 I cap minus 16 j cap minus 8. But we are asked to find the unit vector which is perpendicular to both a bar plus b bar and a bar minus b bar. That is, we have to find a unit vector which is along c bar. Therefore, unit vector along c bar is c bar divided by magnitude of c bar. So this is equal to root over 16 square plus from here we can calculate it to be, let me take 8 common. If I am taking 8 common, then we are left with divided by, you see 8 square can be taken common. If I take 8 square common, then we are left with 2 square plus 2 square plus 1. So this is equal to, it is 2 square, 4 plus 4 plus 1, 9, so it is 3. This get cancelled out. So this is equal to 2 by 3 I cap minus 2 by 3 j cap minus 1 by 3 k cap. And this is the unit vector which is perpendicular to both a bar plus b bar and a bar minus b bar. Fine. Okay, question number 13. A natural number is selected at random from the set A. Find a probability such that the number satisfies the equation x square minus 13x less than equal to 30. Let me recall the definition of probability. Probability is equal to favorable number of cases. Let me give it a name, M, divided by total number of cases. That is, I am giving by N. So here N is equal to, that means all the possible values of the set A, starting from 1 going up to 50. So it is, total number of cases is 50 here. Then to find a favorable number of cases, we have to solve the inequation x square minus 13x less than equal to 30. This implies x square minus 13x less than 30 less than, sorry, minus 30 less than equal to 0. This implies we can write it as x square minus, if I want to solve this, and this is 15x plus twice x minus 30 less than equal to 0. This implies x square, sorry, from this, if I take x common, then it is x into x minus 15. From here, let me take 2 common, then x minus 15. This is less than equal to 0. This implies x minus 15 into x plus 2 less than equal to 0. Now we have two cases here. Case 1, x minus 15 less than equal to 0 and x plus 2 greater than equal to 0. It is a product of two these terms less than equal to 0. That means one of them must be negative, one of them must be positive. So I'm considering, in the first case, I'm considering this to be negative, this to be positive. From here we can say x is less than equal to 15 and x greater than equal to minus 2. This implies if I combine these two, then we have x is greater than equal to minus 2, x is less than equal to minus 5. This is one possibility. Case 2. Now let me consider this to be positive, x minus 15 to be positive and x plus 2 to be negative. This implies x greater than equal to 15 and x less than equal to minus 2. If I combine these two, then we have x greater than equal to 15 and x is less than minus 2. And this cannot be, why? 15 cannot be less than minus 2, so it cannot happen. That means our possibility is minus 2 less than equal to x less than 15. So now what are the possible values of x then? X can be either, sorry, not 0, it is as x is a natural number, it will start from 1, 2, 3 and it goes up to 15. Therefore the values of x can be 1, 2, 3 and it goes up to 15 as x is a natural number. So therefore we can say our favorable number of cases is equal to, so how many values of x we have? 15, so it will be 15. Therefore our required probability is equal to m by n. So our value of m is 15 and our n is 50. So 5 is the common factor, I can cancel by 5, so it becomes 3 by 10 and that is our answer. Okay, I'll stop here. As you can see, it became quite a long video and hope you like the video. And if you have any kind of queries or doubts in your mind, you can ask me or you can comment me in my comment section. I'll be happy to reply your queries. And at last, I would like to thank you for watching such a long video.